Okay, today we're going to be continuing the notes from yesterday on parallel lines cut by transversals. If you need a quick refresher on what are the angle relationships, you can click the link that pops up right now. If not, I'm going to start on the bottom with numbers 7 and 8. So remember yesterday we talked about angle relationships if they are parallel lines, if you have parallel lines and they are cut by transversals. So the first thing you need to do is look at what angles you have and then make an assumption about the relationship. So if you look at number 7, you have this angle here and this angle here. They're on the same side of the transversal on the interior of the parallel line. So therefore they are the same side interior, or remember we said yesterday they could also be called consecutive interior. If you go back up to your chart, consecutive interior angles or same side interior are equal to 180. So all you're going to do is very simply add these two angles together, set it equal to 180, and then solve the equation. So in this case, x would equal 23. If you want to just test out your answer to make sure it works, remember x equals 103. And then so x minus 26 would just be 103 minus 26. 77. 77 plus 103 equals 180, so you know you got the answer right. In the second one, there are two different variables, but there's no need to panic. We can separate these into two separate problems. I personally would choose to do this problem first because it's the easiest. These angles are supplementary, so what plus 68 is 180. You get 112. Now I know that this angle is 112. Now I can look at this angle over here. Forget about 68 for a second. Y, which is now 112, and this angle here are alternate exterior angles, and alternate exterior angles are congruent. So Y, which I can replace with 112, is equal to this angle over here, which is 2x minus 24. So x would equal 60. Now on the back, some of you might want to see these parallel lines running horizontally. That's fine, just rotate your paper. And then again, just pick what angles you would like to start with. I personally would start with these two. I like to just do the supplementaries first because I think that's the easiest relationship to see. So here's 110 and y minus 28. They are next to each other on a straight line. So I'm just going to write 110 plus y minus 28 equals 180. Go ahead and solve this. Okay, that's one way to do it. There was another way you could have done it. See if you could figure out what equation that pops up would have also given you 98. Okay, so that equation makes sense because if this is 110, okay, forget about all these expressions. You know that this angle right here has to equal 70, the one I'm covering up. This has to equal 70. So couldn't you have just said y minus 28 equals 70 and gotten y equals 98? So two different ways to do the problem. Doesn't matter which way you do it, as long as you get 98. Then I would look for other angle relationships. So I have this angle up here. It is exterior, if I turn it back this way, but there's no other exterior angles here. So I'm not going to use any alternate exterior angle theorems. I could say, though, that this is in the same location as 110 and they are corresponding. So therefore, 5x plus 15 is corresponding or equal to 110. 5x would equal 110 plus 15, which is 125. So then x would equal 25. The last one, even though it's a triangle, you still have these two pairs of, or this one pair of parallel lines. So I'm going to pull these out separately. You have two transversals, but see how these angles are like touching this line? So I know I have to focus over here on this line. And I have an expression in this angle here, and I have an expression in this angle here. If I look at these two, these are corresponding to each other, so I know I can set these expressions equal to each other. I would move the x over to get 2x, move the 5 over to get 60, so x would have to equal 30. Okay, what I want you guys to do now is just stop on this for right now. The other worksheet that I gave you is a little bit more heavy with the algebra, so I'm going to do some of these problems with you, and then you can work on the rest of them by yourself, or in your, actually work on them in your small groups. The front is very straightforward. It's just x's, figure out the relationship, set things equal, or set them equal to 180. On the back, though, you'll notice that now we start getting a little bit more intense here. There's some x squared, so might have to factor. We definitely have to factor. So let me do, I'm gonna do with you number 8, 10, and then I'll just do 11. And then you guys can do the rest by yourself. The answers are going to be on Google Classroom, but please try them by yourself first, and then check your answers afterwards, okay? Okay, so number 8. Before you look at the expressions, look at the relationship between 3 and 8. Here's 3, here's 8. 3 and 8, if you want to look at the lines this way, 3 and 8 are consecutive or same side interior. This is the only relationship that equals 180. So angle 3 plus angle 8 has to equal 180 because they are same side interior. Okay, so here's the expression for angle 3. Here's the expression for angle 8. I'm going to add them together. And then I'm going to set it equal to 180. You cannot combine x squared with anything else over here. You also cannot combine 16x with anything over here. So these two are taken care of. You can combine 112 and 131. So that's positive 243, and it equals 180. Now, in order to factor this trinomial, you're going to have to move the 180 over here because this has to be set equal to 0, right? We're looking for the zeros of the solution of the equation. So take 180 from 243, and the answer is 63. Now, even though that number was large, now it's pretty small, and we should be able to very easily figure out the factors of 63. The most commonly known factors of 63 are 7 and 9. Will 7 and 9 add up to give you 16? Yes. And they both have to be positive. So in our case, x could equal -7, or x could equal -9. Now, remember last year in Algebra 1, you would say that these were both algebraic solutions to this problem. However, in geometry, things get a little bit more tricky because you can't have negative angles just like you can't have negative distance. So what I'm going to do is figure out which one of these will actually give me a valid solution. And all I'm going to do is take these and substitute them into my equation. If you do it in the calculator, just be careful, put in parentheses -7 squared plus 112. That gives me positive 161. Make sure it works in the other equation. So 16 -7s plus 131 gives me 19. These are supplementary numbers, so -7 works. Okay? Try it again with -9. I get 193. Now, it's a positive number, but if you're looking for angles that are supplementary, the maximum that they could be is like in whole numbers 179 and 1, or the other way around, 179 and 1. Okay, You cannot have an angle be 193 and have a supplement because it's over 180. So this -9, even though it's positive, is not a valid geometric solution. So for our purposes, x would just only be able to equal 7. Okay? Number 10. So again, go back to the picture. Number 10 is giving you angle 1 and angle 7. So here's 1, here's 7. 1 and 7 are on opposite sides of this transversal, and if you turn it this way, they're on the outside of the parallel line. So those are alternate exterior. Alternate exterior angles are congruent. So if two things are congruent, you just set them equal. So for number 10, you should set x squared minus 7x equal to -x plus 7. Okay? Again, you're trying to factor this, so you want to move all of this over by doing the inverses. So add x minus 7. Add x minus 7. This would all become 0. This becomes x squared. -7 plus 1 is -6x. And there's nothing to add -7 to. It's just a 0, so it's just -7. Okay. The factors of 7, there's only 2 of them because it's a prime number. It's just 7 in itself. Figure out the signs. You have to add these two numbers together to give you -6. So it means that 7 has to be negative, x has to be positive, and it equals 0. So the roots of the solution, or the roots of the function, would be x equals 7 or x equals -1. So again, algebraically, 2 answers. Geometrically, let's figure out what's going on here. We need to take these and substitute them in to make sure that our angles stay positive and that the answer makes sense. Okay, so if x equals 7, okay, here's my original thing. If x equals 7, 7 squared minus 7 sevens is 0. Can you have an angle that is 0? No. So x equals 7 doesn't actually work for us right now, okay? Let's try -1. -1 would be probably the one that you think doesn't work. But -1 squared minus 7 -1s is 8. And if you do it into the other equation, remember x itself is -1. So -1 plus 7 is 8. 8 equals 8. So even though up here 0 was going to equal 0, the angle cannot be 0. The angle can be 8, okay? It would just be a very small acute angle. So for our purposes, again, x can only equal -1, okay? So when you have to factor, just make sure that when you get your two solutions that they both work. One works. There could be a time when neither one of them work, and then you would just say that it's not a valid solution.